Welcome to a new series from game developers. In this case geared toward a new 3D game engine, which version 1.0 has just been released, FLAX Engine. This new engine has been developing for the last years by a Polish team and has a lot of promising features that we will be approaching in this video, to show some of the potential tools that can be used to develop your multi-platform games, as the tool is focused in several different platforms. The first thing that you need to know is that although the tool is open source, and you can download the code from GitHub, the tool is not entirely free, as they have a threshold in the revenues, before having to pay for the tool. In this case, it was expected to be around $3,000 and it has now been increased to $25,000. After that threshold, the developers are expected to pay 4% of the benefits from the game. To download the tool, you will have to go to the project webpage at flaxengine.com. The home page has a list of some of the main characteristics from the engine split in different categories, and in the release post, there is a video with a summary of the main features from the game. It can be coded in C++ or C#, and it also includes a visual editor, which allow non-coders to be able to use the engine to develop their games free from the possible hassles of coding. The graphic possibilities of the engine are very rich, as you will be able to check later on the video. The visual quality promised is very exciting, as it allows a visual quality somewhere between what can be achieved by Unreal 4 and from Unity. Apart from it, it allows performing vertex painting from the engine, advanced terrain creation, vegetation, and foliages. Let's check on the engine. Download the engine from the download link. The installation binary is around 56 megabits, and once you run it, you have the option to enter with a login or as guest without login in. The engine manager is very similar to the one that you can find on Unreal, and in some manner, with the latest Unity Hub. You will find different sections. News, to be informed on the changes and evolution of the engine. Store, which is still not available. Learning content, where you can find the online manual for the tool with some in-depth explanations of the engine features and functions. It is pretty complete, and every time we had a doubt, the manual was able to put us on track. The engine version, which is an Unreal you have to download before start creating projects. When installing it will ask you some of the tools and builds support you want to install, and then we'll start to download it. Projects, where you can download some examples or create your own projects. We are going to put the download of the examples in the background while showcasing the engine with a new project. So once the engine version is downloaded, create a new project based on the existing template. After you selected the folder and the name, click on the Create Project button. The result will be a thumbnail in the project list that you have to click to open the project. Once the project is opened, we can find an interface that is very similar to both Unreal and Unity. Maybe somewhat closer to Unreal, as it seems that most of the references for the engine are drawing more from Unreal than from Unity. In the center, you can see the game world with the objects automatically created by the template. You can switch between scene and game view through the tabs on the top of the central area. On the left, you have a project hierarchy, where all the objects instanced in the scene are available. If you click on any of the game objects, you can see that the transformation arrows appear on the selected object. On the right, you have the inspector that shows all the different properties, parameters, and modules available on the selected game object. On the bottom, you have the Project Explorer view to the folders on the disk where the project is located. On top of the inspector panel, you can find the toolbox. This is where you can find the different options to create new game objects or to add modules, materials, meshes, colliders, rigid bodies, and other elements that you could need to build your game. The toolbox is split as 3 different areas. The toolbox options menu where you can select the different options available, and where you can switch between the different tools that the game engine makes available. The Add Blue icon allows you to create new elements to be added to the game objects or to the scene. The brush icon allows you to paint the game objects. The leaf icon allows you to add trees or grass, or other natural elements to the game. The double triangles or mountains allows creating terrains to be used in your game. Below the toolbox options menu, you have the actual elements that you can modify based on the option selected. Add button. You have 2 panels. In the left one, you can choose between the different categories of the elements stat you can add to the active scene. If you look closely, you can see that we have Basic Models. That allows you to create new cubes, spheres, planes, cylinders, cones, and capsules. Lights. That allows you to add new lights to the game. You can find directional, point, spot, and sky lights. Visuals. That allows you to create new elements associated with any visual element like cameras, probes, skybox, skies, fog, effects volumes, decals, and particle effects. Physics. That adds the rigid bodies, character controllers, all the types of colliders, and several options of joints. Others. That can add miscellaneous elements like animations, bones, CSG primitives, audio sources, and listeners, etc. User interface. That adds different elements for the creation of user interfaces. The other options in the toolbox menu will be addressed in other videos if we see a good reception toward this engine. Let's add a sphere to the scene, by choosing the toolbox add option, and then under the basic models, dragging the sphere primitive to the scene. Let's explore some of the options available to us under the inspector. We can see that we have different options associated with the transforms for the object, the mesh, the materials, the lighting, and the scripts. If you double-click on the material, it will open a new interface where we can modify, not only the material but the shader too, by using visual scripting. Again, a functionality very close to the ones that we can found on Unreal. Let's now add a rigid body, by going to the physics category and then drag the rigid body to the scene. You will see that in this case, the way the engine works is closer to the Godot game engine, than other engines, as the rigid body is an object and not a module or component to other objects. This means that, if we want to move our sphere with physics, we need to drag it under the hierarchy of the rigid body. The same happens with adding a sphere collider. It needs to be dragged to be under the rigid body hierarchy, and not a component of the object itself. If we run the game by clicking on the Run button on the top bar, you will see that our sphere falls to the ground and stays there. Since the game is controlled by a free camera script that captures the mouse, we need to press the Escape key to exit the run mode. How can we add new scripts to the game? Very easy. We have two ways we can do it. The first possibility is to create a new C++ or C# code and attach it to the object. To perform this operation, we need to go to the Project Explorer, and open the content folder and then open the source one. Right-click with the button anywhere in the Explorer and select the type of script that you want to add. Once finished, you will see the file created on the Explorer with the corresponding icon. FLAX doesn't include a code editor, which means that to edit any code, you need to use an IDE already existing on your system. By default, it will try to open files with WordPad. If you want to specify your own IDE, then you need to go to the Tools menu, and then under the Options, you will be able to find the Source Code option, where you will be able to associate FLAX with the IDE of your choice. You can see that the C# code is very similar to the ones that we can found on Unity. The second possibility is to use the visual scripting option. For that, go to the Content folder on the Project Explorer, and right-click anywhere, and choose the new option. A new dialog box will pop up with all the possibilities. Click on the Visual Scripting, and a new window will appear with the Visual Script IDE. It will ask you to choose the base class from which the visual script should be derivated, and then you will be displayed with a blank canvas where you can start to visually code by adding nodes and connections. The working is very similar to the blueprints on Unreal 4, and we will be analyzing it on other videos. By now, the examples have been downloaded, so let's take a quick look. Let's start with the physics demo. The first thing that calls our attention is the visual effects of the movement. Very interesting. We can move along the mini world and interact with all the physics features, by moving in and out of the trigger box, or by firing some balls at the objects. Very interesting. Let's continue with the graphics demo. Very neat affected. Really impressed by the quality of the effects and the speed achieved. We are not feeling any slowdown in the frame rate, and the number of effects is really impressive. Let's finish for now with the first-person example. In the next episodes, if we see that the reception to this video and this engine is good, we will certainly keep exploring all the features it enables game developers to achieve. So, if interested, tell us in the comments below or by liking the video. We hope that you have liked this video. If it has been the case, consider subscribing, giving a like, and clicking on the notification button. If you have any questions, problems, or comments, don't hesitate in putting a comment and we will answer as fast as we could. See you in the next video, game developers.